This is 2020 AMC 10A problem number 10. 7 cubes whose volumes are 1, 8, 27, 64, 125, 216, and 343 cubic units are stacked vertically to form a tower in which the volumes of these cubes decrease from the bottom to the top, except for the bottom cube. The bottom face of each cube lies completely on top of the cube below it. What is the total surface area of the tower, including the bottom, in square units? Now, if you have trouble picturing the structure, you can imagine it as sort of a pyramid that's made of cubes layered on top of each other, progressively getting smaller. So we can see that since we have their volumes and we know that they're cubes, we have the side lengths as 1, 2, 3, 4, 5, 6, and 7. So these are our side lengths. So now that we know our side lengths, we can move on to finding surface area. And what we can do here is we can find the sum of all the surface areas of the cubes individually, and we can subtract what's being covered or what we have to not count after. So for the sum of the surface areas of each cube individually, we simply have 6 times the faces of all of the cubes added, since we can factor out a 6. We're multiplying by 6 for each cube. So we have 6 times 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. And this turns out to be 6 times 140 or 840. And now we have to subtract all the sides or faces that are covered or that we don't count. So I'll just draw only 2 of these cubes from a bird's eye view. So say this is the 7 cube and this is the 6 cube. And I've just deleted all the others for convenience. They're not deleted from the problem, just to give you an understanding of how this works. So we know that if you looked at it from the side as well, it would look something like this, which means this area here, this area that I've shaded, that is inside the structure, which means it's not counted. So I can draw it completely like this. So that structure there, that's actually inside the whole structure as a whole, which means we don't count it. And since we counted each of the surface areas individually, that means we counted this area twice, once from the 7 cube and once from the 6 cube, since they both include this area as part of their surface area. And if we extend this idea to each of the cubes one after the other, we see that the next cube simply comes on top like this, and this is the 5 cube. And it also has an area like this that's covered by both the 6 cube and the 5 cube, which means we have to subtract twice one face area for each of these cubes, except for the 7 cube because its face touches the ground below. So we have 2 times 1 plus 4 plus 9 plus 16 plus 25 plus 36. And this is 2 times 91, which is equal to 182. So now subtracting these two numbers, we have 840 minus 182 to give us a final answer of 658, or an answer choice of B.